This lesson continues with what we saw last time when we're combining functions. Page 10 in your notes, this is still section 7.6. A new way to combine functions is what we're going to call the composition of functions. And this way has a special way. So when you see this, we read this as g of f of x. There's two different ofs in here, okay? This means that we're actually doing function notation twice. So we also write it like this, where we input the x into the f function, okay, so just this piece, input the x into the f function, then whatever answer we get out, that whole thing, whatever answer that is the new input for the g function. This will make sense, I think, as we do it. Here are your steps for you to see this. Evaluate the inner function first, and then input your answer to that into the outer function. So I like to use colors for this. It helps me a lot when I see what's going inside and outsides of things. So we're going to do whenever you see this, always rewrite this to be g, big parentheses, and then on the inside, we're going to do f of 2. Okay, just like we saw here in our notes, g of f of x is g parentheses f parentheses x. It means we do the inside part first. So what's the inside part? F of 2 equals 2 cubed. That's its inside part. So f of 2 is equivalent to 2 times 2 times 2, which is 8. So this statement is going to help us with this piece. So now take your g function, g of equals blank squared plus 7. And now we're going to input f of 2 in here. And what was that f of 2 equivalent to? It was equivalent to 8. So we're going to put in 8 and 8. So now we say g of 8 equals 8 squared, which is 64, plus 7. 64 plus 7 is 71. G of, now this is 8, that's true. When you put 8 in, that's what you got. Where did that 8 come from? That 8 came from f of 2. So it's g of f of 2 is equivalent to 71. Okay, so we did this inside part first, this whole thing. We found an answer to that, and that's what got plugged in as the input for our g function here. So g of f of 2 is 71. Let's look at another example. Again, always that inner function first. So this one right here, what we need to input first is this little -5, and let's rewrite this. So when we rewrite this, we get g of, and then inside that we'll put f of -5. Do that one first. F of -5 is -5 minus 2 -7. And then when we come over here to our g space equals space squared, we'll input -7 and -7. Negative times a negative is a positive, so positive 49. So g of -7 was 49, or g of, remember what we really inputted here is we really inputted the f of -5. There's our answer. Again, let me highlight the inputs for you. We input f of -5, we found out what that was, and that's what we put in to our function. Now, what happens if we take the exact same two functions, Okay, it's exactly the same for 8 and 9, but now we switch the order. So instead of doing g of f of negative 5, we do f of g of negative 5. So this way looks like this, f, and then inside we input the g. So we're going to say g of negative 5. Means we do this piece first. So g of negative 5 equals negative 5 squared. G of negative 5 equals positive 25. Remember, negative times negative. So that answer is going to go into our f function, f of space minus 2. And it's 25 that's going in. So 25 and 25. And then simplify. F of 25 equals 25 minus 2 is 23. So f of, remember what we input was g of negative 5. That is our answer, f of g of negative 5. Again, we input this whole thing, so we had to find that whole answer, and that's what we ended up inputting into our f function. Notice something. Notice how your answers to example 8 and example 9 are different. Okay? So the order of composition matters. Order of composition matters, makes a big difference. This is why we always make sure that we do the inner function first. Okay? Because which one's the inner one is going to change the answer for us. Let's look at a graphical example. So here's that same graph you saw in your last lesson, but now we're going to use it a little differently. We're going to use it for composition. So first, we're going to find the inputs here. So we need to say f of, and what is g of 6? Okay, take a look on our graph. G of 6, right there, which is negative 3. So then we go to our graph, and now we look for negative 3 and say, what is f at negative 3? F at negative 3 is positive 6. So we do that inside part first, get a number out, then that number, negative 3, goes in. Okay? So we end up jumping around the graph in kind of this fun way here. Let's look at another example. Find the inside part. What is g of 0? Whoops. So when we look at g of 0, here's 0. G at 0 is negative 5, so that's what comes in here. Now go back up to your graph and look for f of negative 5. So negative 5, and for f, that's 7. Let's look at a couple more examples. So, for example here, when we have f of g of negative 9, we're going to have f. We need to find g of negative 9, so negative 9. Right here, g of negative 9 is negative 4. F at negative 4 is a positive 7. Now we're switching up the order a little bit. G comes first, so g, find f of 6. Here's 6. F of 6 is at 5. What is g at 5? G at 5 is negative 5. Scroll down a little bit here. G, and then f negative 2. At negative 2, f is positive 6. F at negative 2 is positive 6. G of positive 6 is negative 3.